Hey guys, welcome back to chapter 17. What we're going to look at now is calculating the change in pH if a strong acid or a strong base is added. So we've got our buffer solution, we add a strong acid. What's the new pH? We've got our buffer solution, we add a strong base. What's the new pH? That's what we're going to be calculating. To break down these problems, we're going to break them into two parts. So part one is the new part. Part two is what we've been doing, essentially. Okay. So first, we're going to do a stoichiometric calculation. So we've got to calculate how the addition of the acid, of the strong acid or strong base, changes the amount in our buffer. So when a strong acid reacts with the conjugate base, it's going to make more of the weak acid. When a strong base reacts with the weak acid, it's going to make more of the conjugate base. So first we need to see what changes when we add the strong acid or we add the strong base. Then once we know how things change, we can calculate the pH based on the new amounts in our buffer. So here you can either do the traditional ice table calculation, or you can use the Henderson-Hasselbalch equation. Either way, whatever works better for you. Okay, so let's just dive right into a problem. Let's just get into it. So we've got a 1 liter buffer solution that is 0.1 molar in our weak acid and 0.1 molar in the conjugate base. Calculate the pH of the solution after we add 0.025 moles of a strong acid. Okay. Lots and lots of information, so we really need to be organized as we work through this problem. So the first thing I'm going to do is the first thing I've done for every single buffer problem. I'm going to get the equation for a buffer onto my paper. So my buffer is a generic buffer in this case. So weak acid will react with water to produce the conjugate base plus hydronium. Okay. So write the equation for your buffer. The next thing we're going to do is write the equation for the addition. So in this case, we're adding a strong acid. So that's going to be step 2, is writing the equation for the addition of that. So we're going to have a strong acid. Which part of this buffer is that strong acid going to react with? Is it going to react with the weak acid, or is it going to react with the conjugate base? Yeah, an acid is going to react with the conjugate base. So a strong acid is going to react with the conjugate base. This is a one-sided arrow. So all of the strong acid is going to react. Every single molecule of the strong acid is going to react. So if we've got strong acid, conjugate base, that's going to make more of this guy. Okay. Step 1, balanced equation for the buffer. Step 2, equation for the addition. Okay. Now that we have a picture on our paper of what is going on, now we can start to quantify this process. And we already did this. So if the acid is added, what will it react with? And then write the balanced equation depicting that change. So now we have a picture of what's going on. We can go ahead and start to work through this. We can start to quantify it. I am going to depict for you a new table. This is not an ice table. Tables just happen to be very handy tools to solve problems. So here is our stoichiometric table. So this table is utilizing that second equation that we wrote. So our strong acid, our conjugate base, and then what it's forming. Okay. Moles before. So the number of moles before we add our strong acid or strong base. So before we add our strong acid, how many moles do we have? Well, there's none because we haven't added it yet, right? And how much of our weak acid and conjugate base did we have? Well, our problem tells us 0.1 and 0.1. Okay. Now, moles added. Are we adding any of our conjugate base? Are we adding any of our weak acid? No, we're not adding anything. We're just leaving those alone. So nothing gets added there. But we are adding our strong acid. So we're adding 0.025 moles of this. Okay. All right. So now we just got to read down the table. So moles after. Well, after this has been allowed to react. So after we mix these two together, magical chemistry happens. What's left on the other side? So all of the strong acid is going to react. So we're going to be left with none of that at the end. So that's going to be 0. What did that strong acid react with? It reacted with our conjugate base. So what that tells me is it's going to require 0.025 moles of the conjugate base to be used up. So after, we're going to have the 0.1 that we started with minus the 0.025 that we used. So the number of moles of our the number of moles of our conjugate base that we're going to be left with is just simply going to be 0.075. Okay. All right. Lastly, our weak acid. So if we used our conjugate base, we created more of this. The amount of weak acid is going to be 0.1, and we created 0.025 extra moles of that. So we created more of it. So the amount of weak acid at the end is 0.125. So this is the new step. We're putting in a strong acid. We're seeing how that changes the concentrations within our buffer. Now we can calculate the pH of our buffer. So instead of using the 0.1 and 0.1 given in the problem, we're going to use the numbers that we just calculated. Okay. So now we're going to say the pH of our buffer is going to be pKa plus log of our base over acid. Okay. So pH equals, did I give the pKa of this ever? I don't know if I did. Let me see. Nope. Okay. So pKa, again, I failed to give it to you guys. It's an arbitrary one, so let's just make one up. So let's say that the Ka equals 2.5 times 10 to the negative fifth. Okay. So pKa is just going to be the negative log of that. So pKa, negative log 2.5 times 10 to the negative fifth. So pKa is 4.60. All right, so 4.60 plus log. So the concentration of our base after everything was added is the 0.075. And concentration of our acid after everything was added is the 0.125. So pH equals 4.60 plus. So I'm going to take 0.075 divided by 0.125. And then I'm going to take that's 0.6. I'm going to take the log of 0.6. And that is negative 0.22. So pH equals 4.60 minus 0.22, 4.38. Okay. So two-part problem. Step 1, determine how the addition changes those initial concentrations. Step 2, use the new concentrations to calculate the pH. I hope you guys found this helpful.